I hope we're going to dispel the theory that putting a stake in the ground at an angle works better than putting it in straight. The theory behind this is, pretend this piece of paper is the ground on which your tent is standing. So I have a leg of a tent standing right here on this edge of the paper. I drive my stake in on this side right here, and the resistance is created by this big block of dirt right here. So as the wind blows, this block of dirt pushes against the stake, or the stake pushes against that block of earth, and that whole block of earth holds it in place. When I take and drive my stake in the ground at an angle, this is what happens. My tent is still standing right here, my stake is driven right here, but I've cut the block of earth in half, okay? The actual reduction in holding power is not 50%. It's about 30%. So if a standard stake driven in like this holds 1,000 pounds, driving it in like this should reduce it by 30%, or 300 pounds, which would make it a 700-pound stake. We need to define angle and straight. According to all of my testing and the study done by IFAI, straight is defined as straight up and down, tipped back, straight up and down, still straight up and down. When I get to 15 degrees or more, now I'm reducing my holding power by 30%. The stake that we have in the ground is driven in at an angle right now. Get back behind here, I'm sorry. Okay, we're just starting to get a minor amount of creep there.
500.
At 500 pounds, and let's bring it forward a little more. Okay, I'm going to say that was a 500-pound failure there, okay, because now it's starting to walk forward. It's bumped up to about 700. Go ahead, just a little bit. Let's just stand back and let it go. Yeah. Just a little bit more. And we're not gaining anything. That's good. It tickled up to about 800, okay? So this stake driven into the ground is about a 500-pound holding power. The stake next to it is the same stake, but it's driven in correctly. All right, go ahead. We're zeroed out?
Yep.
All right. And let's hold it right there. Okay, we're about 700 pounds. Okay, so 500, 700. I got a 200-pound difference by driving it straight versus driving it at an angle. And let's go ahead just a little bit more. And we are at 13. That's totally failed there. And I think you should stop there. Okay? We're totally failed, but yet we're up into the 1,800-pound range. So you can see there was a totally different story here. The initial failures, not a whole lot different, but the actual total holding power, considerably higher when you drive them straight down versus when you drive them at the angle, okay? That loss of that soil wedge in front of it by angling the stake just decreases the amount of hold power and it increases the speed at which it fails.
For more information, visit us at www.gettent.com or call us at 419-586